Hi class, very good evening. Ankit Mr. this side, and I hope I'm audible to everyone, right? Candidate, just let me know I'm audible. Can anyone just confirm me in the message box so that I can continue? Guys, anyone kindly confirm me once again. I'm sharing my screen and I hope I'm audible, right? So, hello Ananya, Apeksha, Rakesh, Darshan, how are you candidate? Pragna, I hope everyone is doing good, right? So we have already spent like 2 days and we have learned multiple things from linear regression to logistic regression, right? Now, what we are going to understand, because yesterday we had just completed the overall mathematical portion of logistic regression, right? First of all, let me just share this notebook with all of you so that you can practice it parallelly. Okay. So this is the link, and this one is just the theoretical portion or the mathematical portion that we have just covered. Okay. Now you can take a reference of this same notebook. If you want to do it parallelly, you can do it with me. Let me just share this. This is the Colab notebook. Okay. Now what you have to do, it's not like कि आप इसी फाइल पे वर्क करोगे. Just once you open this code notebook, just go to this file option and create a copy of this file, right? You can just click on this, save a copy in drive. If you directly work in this file, it will not allow you to do this, or some suppose like it allowed this, but the problem is ki I'll not able to perform the rest code, right? So just click on that particular URL and go to this file option and click on this, save a copy in drive. Once you save this as a copy, then you can edit your file as well, right? And second thing is, this is the GitHub profile, and just usually created for this like kind of training session only. So you can do one thing, whatever I am like teaching you on day-to-day basis, you will get the complete notebook, and I'll upload the notes, theoretical notes as well, right? In this particular GitHub profile, right? So you can just have a look of this GitHub profile where you will find the day-to-day codes and notes as well, right? I've shared two URLs. The first one for the code notebook, and second one is for the GitHub profile, where you will find the day-to-day notebooks as well, right? So I think it's good to go, right? So shall we just continue, everyone? Just let me know. Shall we start? कल का जहाँ पे पार्ट पेंडिंग था वहीं से हम कंटिन्यू करें. Everyone, just say yes, no. Ananya, Apeksha, and other candidates. I hope everyone is like got this URL. So let me just continue with the rest part, right? So yesterday we started with the logistic regression, right? And we know that logistic regression is just mainly used for the classification problem, and we can use it for like binary classification as well as multi-class classification, right? So what I'll do, let me just rerun this code, okay? Because I have already shared the URL of this notebook. So what you will do, just go to file and click and create a copy of this like notebook, okay? And then probably run your code. So let me just run all the code. It will hardly take a minute, right? Step one is all about to import all of your modules, right? And we already know what exactly the logistic regression is, कैसे काम करता है, right? We perform some sort of operation. What was like the sigmoid function? We know the formula of sigmoid function is like 1 divided by 1 plus np dot e raised to the power minus x, and minus x is nothing, just the input, or input is like y is equals to mx plus c. That was we generally got from the equation of line. That is my sigmoid function, right? So we perform this kind of equation, right? Now what we have to do, let me just share the dataset link. This dataset link is already given here. Now we'll just call the data and now we'll try to build a model, right? Based on this logistic regression. Okay. If you want to do it parallelly, you can do it along with me. Okay. So first of all, I'll copy this URL and let me open the URL. Okay. This is a insurance dataset, right? Let me open this URL inside a Google Sheet. Okay, and इसे public भी कर देते हैं so that you can also use this, right? So go to this file and you will get this option share, and inside this share you will get this option which is publish, right? Make sure once you publish this data na, so anyone can use this. So it has to be like in a comma separated value so that everyone can use this. Now just click on this publish. Once you publish this is the final URL. We have already used this kind of method in previous classes as well, right? Now this is the URL of this dataset, and even you can also use this URL right now. So let me just share the URL as well. Apeksha, you can copy this URL, right? And if you just paste this URL, so the data will get automatically downloaded, right? Now let's just start candidate. So step one was about to load the important module which we have already performed. So there is no requirement to importing the modules again and again, right? Now let's just start with the step two. So step two is, and see whatever we'll performing now we'll try to perform in a step way so that you can easily understand the structured format of machine learning overall process, right? Step two is to load dataset, and we know that the data set is at this URL, so you can just paste that URL, the same URL, right? जो मैंने copy किया है, and just I have given the same URL here. Okay, you can copy this URL, right? Now once you paste the URL, just try to show the URL as well. This is my URL, right? Now we know that because this URL ends with the CSV, so we can use the pd dot read underscore CSV extension to read out this data. Once you read this data, na, you can store this data inside data frame, and if you just want to check some sample, so inside some sample method you can give it two. So this will try to read out the two sample of data. Perfect. Candidate, I hope everyone is getting the same, right? Is that clear? How many of you are like performing parallelly? Just let me know. Is there anyone that doing it parallelly? कोई है जो साथ साथ perform कर रहा है? In case of any issue, you can just share your screenshot or let me know in the message box. ठीक है? Ananya, Apeksha, Rakesh, Pragna, and the other candidates, right? The strength is very less today. No issue. They can get recordings. Okay. Now we have successfully imported the data, right? Now we know that we have to perform some sort of EDA, right? So I'll not waste time on day-to-day basis to perform the EDA again and again. So what I'll do, I'll just simply do some basic EDA like df.shape, df.head kind of. You already know all these things, right? It will try to show the five data. Now we know that na ki machine learning only operates with the numerical data, and here we can see that ki age तो मेरा numerical है, but we know that कि मेरे पास कुछ कॉलम ऐसे हैं with the help of df info where some columns are like object data, and object data are like categorical or like textual in data. And what is that? एक तो मेरा gender data आ रहा है, textual है, और एक मेरा marital status आ रहा है which is also a textual data. Okay, so we need to convert this textual data into like the numerical one, and we have a technique. The technique is called feature engineering, where we can convert the textual data to numerical one, and we'll perform the same, right? अभी हम सीखेंगे कि वो कैसे convert करता है. Okay, so in this info we got this कि कौन कौन से हमारे integer है and कौन कौन से हमारे object है. I hope everyone is getting the point, right? So you can just check कि df का मेरे पास कौन कौन से columns है. All these are my columns, right? A से लेकर के insurance bot तक का, and you can some check samples की मेरे data में missing values तो नहीं है. If it is, then you can just fill out those missing values, or you can drop out the missing values as well, right? So how to check df dot is na, and you can finally just apply the sum as well, right? Here we are getting the zero values since all the values are zero, so no missing data. Now you are like कि सर आप तो खाली मतलब क्लीन डेटा ले रहे हो, थोड़ा अनक्लीन डेटा लोगे तो हमें भी समझ में आएगा. ऑफ कोर्स बिल्कुल आपको भी समझ में आएगा, बट द थिंग इज कि लेट जस्ट अंडरस्टैंड द मॉडल बिल्डिंग फर्स्ट ऑफ ऑल. ओके, एक बार मॉडल बिल्डिंग हमें समझ में आ जाए, वेदर इट इज लीनियर रिग्रेशन, लॉजिस्टिक रिग्रेशन, केएनएन हो गया, सपोर्ट वेक्टर मशीन हो गया, डिसीजन ट्री हो गया, रैंडम फॉरेस्ट हो गया, की मीन्स हो गया, और एनी सॉर्ट ऑफ ML algorithm, whether it is like supervised हो या unsupervised हो. Once you got to know कि ML मॉडल काम कैसे करता है, then we know that ना कि ज्यादातर टाइम ना आपको डेटा ट्रांसफॉर्मेशन पे जाता है. There is a step, there is a pipeline that is called ETL, and we know that ETL means first of all you need to extract the data, then you need to transform the data. I hope everyone is clear with the term, right? And the third one is you have to load the data set and for whatever purpose, like आप Power BI में reporting बनाने के लिए कर रहे हैं, then you can load that same data set. Okay, and if you just want to perform some machine learning model building, तो वो भी आप load करके कर सकते हैं. There is another thing that is called ELT. ELT is like we know that extract करना, load करना and then transform करना. And all these parts are generally performed by the data engineer. Data engineer will be there to just perform all these parts. But sometime as a data analyst or as a data scientist, ये सब काम हमें भी करना पड़ता है. And the another term is also called ETLT. And you know that ETLT means extract भी करना, transform भी करना, right? Then load करना and then again transform करना. And you know that कि load करने के बावजूद भी data transformation की requirement पड़ सकती है for different use cases और for different departments, right? And सबसे ज्यादा most consuming time जो है this transformation part, because इसमें सबसे ज्यादा टाइम लगता है हमारा. एक्सट्रैक्शन इज ठीक है, somehow मैनेजेबल, कि हमें 10 जगह से डेटा लेके आना है, हमें पाइथन से SQL से डेटा लेके आना है. वी कैन गेट डेटा फ्रॉम वेब स्क्रैपिंग एज वेल, वी कैन गेट डेटा यूजिंग एक्सेल एंड CSV. हम हर जगह से डेटा ला सकते हैं. बट द मेजर थिंग इज उसे ट्रांसफॉर्म करना पड़ेगा ना. एंड द ट्रांसफॉर्मेशन इज लाइक डेटा क्लीन करना, डेटा मर्ज करना, डेटा ज्वाइन करना, डेटा ब्लेंड करना. ऑल दीज आर स्टेप्स ऑफ दिस ट्रांसफॉर्मेशन. मिसिंग वैल्यूज फिल आउट करना, मिसिंग वैल्यूज को रिमूव करना. तो 70 to 80% टास्क तो हमारा ट्रांसफॉर्मेशन पे जा रहा है. वंस द ट्रांसफॉर्मेशन इज ओके, देन यू कैन प्रोबेबली लोड योर डेटा फॉर नेक्स्ट स्टेज, वेदर इट इज लाइक डैशबोर्ड डेवलपमेंट या फिर आपका मशीन लर्निंग का पार्ट हो. ओके, सो दिस वन इज वेरी क्रूशियल स्टेज. दैट इज द रीजन अभी फिलहाल हम उसके लिए प्रॉपर डेडिकेटेड टाइम देंगे, हाउ टू एग्जैक्टली ट्रांसफॉर्म. और ये सब आपने डेटा एनालिस्ट वाले यानी पांडास के थ्रू सीखा भी होगा थोड़ा बहुत. परफेक्ट. नाउ द डेटा इज ऑलरेडी नीट एंड क्लीन. गाइस, आर यू गेटिंग माय पॉइंट ना? ये सबको समझ में आ रहा है? एवरीवन, प्रज्ञा, दशमी, राकेश, अपेक्षा, अनन्या एंड रेस्ट 10 कैंडिडेट्स. गाइस, आर यू गेटिंग माय पॉइंट ना? ऐसा तो नहीं समझ नहीं आ रहा? ओके, सो नाउ लेट्स जस्ट मूव टू अनदर स्टेप. ठीक है, हमने बेसिक यहाँ पर ईडीए परफॉर्म किया. एंड नाउ इनसाइड दिस ईडीए लेट्स जस्ट डू सम ऑटोमेशन काइंड ऑफ स्टफ. नाउ व्हाट काइंड ऑफ ऑटोमेशन? आई जस्ट वांट कि मेरे को इसका सबसे पहले तो डिस्क्राइब कर दो. So df dot describe, and we know that describe is like the statistical analysis. Once you run this, जितने भी numerical column है ना, उन सब का statistical information आपके सामने आ जाएगा. Like the minimum age is this, and the minimum age is 22, and the maximum age is this. The minimum salary is something 28,000, maximum is इतना. Credit score you know सबसे कम 580 है, and maximum is this. Same as it is पहले claim किया था, no. कभी claim किया, yes. Same insurance by no and insurance bound, yes, right? This is the numerical describe. You know that कि numerical के साथ साथ you can do it for like object data as well. So what you can do, उसके लिए आप क्या लिखेंगे? df.describe. And you know that, I hope you already knew this, right? कि you have to write this include is equals to object. Object, we know that object is a categorical data, and object means कि आप यही describe करो textual information के लिए. And we know that कि हमारे पूरे data में total 85 data rows हैं, and rows are sometimes not sometimes, we generally refer rows as instances. Instances are like number of records. Let me just write this. Instances, rows and records all are same, right? कोई इसे rows कहता है, कोई instances कहेगा, and कोई records कहेगा. You can just simply say we have 85 instances, 85 rows, 85 records. All of them are same, right? सबसे ज्यादा मेल रिकॉर्ड्स है, एंड उनकी फ्रीक्वेंसी 43 है. सेम एज इट इज मेटल स्टेटस में सबसे ज्यादा मैरिड है, एंड उनकी फ्रीक्वेंसी आर लाइक रिपीटेशंस, उनकी फ्रीक्वेंसी 59 है, राइट? So we have described this textual data as well. Now what to do? We need to break this textual and numerical data into two parts. So let me just write this as a text columns. I just want कि मेरा text column अलग हो जाए. For that I'll just say कि df dot select data type. I hope ये आपने पढ़ा होगा. This whatever we are performing ना, ये transformation और EDA का part है. And inside this select D types में you can just simply write कि object लिख लो. ऑब्जेक्ट मीन्स कि उन्हीं कॉलम को लाके देगा जो आपके ऑब्जेक्ट होंगे. एंड यू जस्ट वांट कॉलम्स, आपको पूरा डेटा नहीं चाहिए. सो यू कैन जस्ट राइट इट कॉलम. वंस यू रन दिस, यू आर गेटिंग दिस ओनली जेंडर मिल रहा है और एक मैरिटल स्टेटस मिल रहा है. इन दिस वे यू कैन जस्ट सिंपली सिलेक्ट द ऑब्जेक्ट कॉलम्स, यानी टेक्सचुअल कॉलम मुझे मांगना है. इन द सेम वे मैं इसको कॉपी कर लेता हूँ और मैं कहता हूँ नाउ दिस टाइम ना मुझे टेक्स्ट कॉलम नहीं, लेट मी जस्ट pick numerical column, and in short I'm just converting this to num column. Now you were like कि सर ये कर क्यों रहे हैं आप? लेट मी वेरी क्लियर कि ये हम इसीलिए कर रहे हैं ना, क्योंकि टेक्सचुअल कॉलम पे अलग तरीके का एनालिसिस होता है, न्यूमेरिकल कॉलम पे अलग तरीके का एनालिसिस होता है। वाई वी आर डूइंग दिस, अभी ये जस्ट अगले स्टेप में आपको क्लियर हो जाएगा। एंड इंस्टेड ऑफ दिस ऑब्जेक्ट, बिकॉज हम डेटा फ्रेम से वो डेटा टाइप कॉल कर रहे हैं, दोज आर लाइक नंबर इन नेचर, सो यू कैन जस्ट राइट नंबर्स, एंड नंबर्स आर लाइक जो न्यूमेरिकल कॉलम्स होंगे। एंड यू गॉट टू नो कि यार ठीक है, इसने टेक्सचुअल अलग स्टोर कर लिया, न्यूमेरिकल अलग स्टोर कर लिया, बट वाई? द रीजन वाई इज क्योंकि हमें टेक्स्ट डेटा पे ना टेक्स्ट के अकॉर्डिंग एनालिसिस करना है, एंड इन जनरली टेक्स्ट पे ना हम फ्रीक्वेंसी एनालिसिस करते हैं, राइट? फ्रीक्वेंसी मींस वैल्यू काउंट एनालिसिस करते हैं, राइट? लेट मी जस्ट डू दिस। फॉर दैट व्हाट आई विल डू, मैं फॉर लूप रन करूंगा फॉर आई इन विच वन, फॉर आई इन दिस टेक्स्ट कॉलम। एंड आई नो दैट कि मेरे पास आई के पास फर्स्ट टाइम जेंडर आएगा, सेकंड टाइम मेटल स्टेटस आएगा। ओके, व्हाट आई विल डू, मैं अपने डेटा फ्रेम पे जाऊंगा, एंड डेटा फ्रेम पे आई विल सिंपली कॉल दिस आई कॉलम, एंड आई नो दैट कि पहला आई मेरा जेंडर होने वाला है, बिल्कुल जेंडर होने वाला है। एंड वी हैव ऑलरेडी लाइक कंप्लीटेड दिस कि किसी भी टेक्सचुअल कॉलम पे यू कैन सिंपली रन दिस वैल्यू काउंट। आई होप एवरीथिंग इज लाइक क्लियर विद दिस टर्म, है ना? वैल्यू काउंट सभी को पता है। एंड वी नो दैट कि वी हैव अ डिस्प्ले फंक्शन, दैट डिस्प्ले इज जनरली डिजाइन टू डिस्प्ले द डेटा फ्रेम। ये डिस्प्ले फंक्शन सी, आप लोगों ने अभी तक प्रिंट फंक्शन पढ़ा होगा, राइट? बट वी हैव अनदर फंक्शन विच इज कॉल्ड डिस्प्ले फंक्शन, और इसका कुछ कलर नहीं आ रहा है बिकॉज दिस डिस्प्ले फंक्शन वाज अ पार्ट ऑफ पाइथन वर्जन 2। ठीक है, डिस्प्ले फंक्शन के थ्रू यू कैन डिस्प्ले योर डेटा फ्रेम लाइक दिस। देखिए, दोनों डेटा फ्रेम यहाँ पर मेरा आ रहा है, इंस्टेड ऑफ दिस डिस्प्ले अगर मैं यहाँ पर प्रिंट यूज करता, आई विल गेट रिजल्ट समथिंग लाइक दिस, जो कि थोड़ा सा अजीब सा लग रहा है। एंड यू नो दैट ना कि मुझे डिस्प्ले यानी कि डेटा फ्रेम फॉर्म में डिस्प्ले कराना है, दैट इज द रीजन आई एम यूजिंग द डिस्प्ले फंक्शन, एंड डिस्प्ले इज इनबिल्ट फंक्शन। एंड आई एम गेटिंग कि मेरे पास यहाँ पर जेंडर भी मिल रहा है, दैट इज माई वैल्यू काउंट एनालिसिस, मेल इतना, फीमेल इतना, मेरिट इतना, सिंगल इतना, राइट? एंड मेरे को पूरा एक इंसाइट मिल गया कि मेरे पूरे डेटा सेट में मेल कितने हैं, फीमेल कितने हैं। इफ यू गाइस आर लाइक कि सर ये तो बेसिक सा एनालिसिस है, इसमें ज्यादा कुछ तो है नहीं, लेट्स जस्ट डू वन थिंग ना, इंस्टेड ऑफ दिस व्हाट आई विल से कि यार एक काम करो, मेरे को पता है कि किसी भी डेटा फ्रेम में, गाइस ये समझ आ रहा है, इट्स नॉट लाइक ना कि मैं थोड़ा फास्ट हूँ, ऐसा तो नहीं है। सी, थोड़ा फास्ट की रिक्वायरमेंट भी है, द थिंग इज दैट वी हैव मल्टीपल थिंग्स टू बी कवर्ड, राइट? एंड थोड़ा सा अगर किसी को भी डाउट होता है, जस्ट लेट मी नो, ओके? एंड दीज आर द थिंग्स दैट ऑलरेडी बीन कवर्ड, ये सब आपका डीए में हो रखा होगा, ओके? आई नो दैट कि किसी भी डेटा फ्रेम में दिस पार्ट इज कॉल्ड इंडेक्स एंड दिस पार्ट इज कॉल्ड वैल्यूज। कैन आई जस्ट से कि आई कैन कन्वर्ट दिस इंडेक्स टू एक्स पार्ट लाइक एक्स वैल्यूज, और इसे मैं वाई में कन्वर्ट कर दूं, वाई एक्स एंड वाई, इट्स लाइक बेसिक एक्स एंड वाई, एंड उसके बेस पे मैं एक ग्राफ बना पाऊंगा यहाँ पर। So let me just do this. I think someone, sir, please don't use Hindi. Okay, got it, Apeksha, got it. Perfect. So what I'll do ki, let me just use this one. DFI is like data frame, the I individual I column, and what I'm just doing, checking the frequency of the values, right? So you can just do one thing. You can pick the index, and index is like the X value, right? So you can simply convert this to index, and the second is Y, and you can get the value of Y from the values part. So you can just copy the same one, and instead of the index you can just simply write the values one, right? Now you got to know key, okay, we have picked the value for x and value for y as well. Now you are already aware with the term of matplotlib, so you can do one thing, let's just create a bar graph, and inside the bar graph you can simply give the plt dot bar x and y, and let me just give the title as well. And the title is like I column wise analysis, and we know that the first I is like gender and second I is like marital status. So you can just write like this, I wise analysis, and we know that the first I is gender, so it will become gender wise analysis, right? And the second I is like metal status, so it is like the metal status wise analysis. Perfect. Now once you run this, let's just show this graph, and if you want to show the color as well, so you can give a color as well, right? Plt dot bar x and y, and let me just run this, right? So this is the kind of like loop you can run, and instead of this one, we have simply performed the EDA analysis using the loop, right? If you want to show the values as well, you know that key. Let's just store this plt dot bar inside axis, and what you can do, we have a method that is called bar label, and inside a bar label you can just simply give your access data or access or like chart data, right? So just simply pass this access data and this will give you the value as well. So instead of like performing this kind of like analysis for the textual data, like data frame analysis, you can convert this data to into a like visual kind of analysis. If you want the different color coding as well, so you can do one thing. Inside this we have a like palette option. Let me just check, do we have a palette option? Color is equals to sns dot color palette, and inside this color palette let's just use the cool is like the color palette, and this will try to give the palette. Okay, yes, this is the palette, right? The first one is male and the second one is female, and same as it is the married one and the single one, right? Now you got to know ki, okay, why we have converted this data to textual and numerical column, because for the textual column we generally perform a frequency analysis where we just want to check which kind of data like presenting how many times. Okay, in the same way do the same analysis for the num column or like numerical column, and we know that numerical column we generally perform the distribution analysis. Distribution analysis is also frequency analysis, right? But it's completely based on the numerical one. Okay, so let me just use the numerical distribution, numerical distribution analysis. Now what to do? Just again run the for loop for I in num columns, and we know that just pick the data frame and this data frame with the help of I column, and we know that the first I going to be is like the age. And what we want, we just want the overall distribution of age, just like a histogram. So you know that you can just simply say this. Okay, let's just do one thing. Instead of directly calling this, you can convert this to histogram, and for that you can just say key plt dot hist or sns dot hist as well, right? You can say sns dot hist. Okay, so sns dot hist plot, and inside this hist plot you can give this data, and you can just say plt dot show. Let me just give the title as well, right? If we want to plot a subplot now, you can do it also, right? Plt dot title, and inside a title it is like the I wise analysis. So let me just say this, like the first column name is age now, so you can just say age wise distribution, age wise distribution analysis, right? Now it will become, okay, we have a multiple graph and each individual graph has their own title, right? That is dynamically derived. And you can just check, okay, we have a kind of normal distribution, not exactly the normal distribution, but kind of normal distribution of my age, where the minimum value could be like something less than 25 and the maximum up to like 50. Okay, these are the like analysis that you can perform with the help of a Python programming and with some basic sort of matplotlib and the Seaborn, right? And if you just want to perform like some color coding as well, you are already aware with this, you can do some experimentation part with this one, right? Now we have performed some basic EDA candidates. Now it's time to just focus on the machine learning portion and just basically start with the logistic one. We know that logistic regression we'll use for the binary classification, right? Now let's just call our data again and try to understand this data. So our data is like data frame df. Okay. Now the problem with this data frame is like we have a textual column, and the first textual column is gender and second textual column is metal status, right? So what we want, before just to converting this to numerical one now, let's just perform which is very important one, that is called correlation matrix, and the correlation matrix generally perform on the numerical one, and you can use this df.core. Once you run this can probably give you the error because due to the textual information. Now you can just say numerical only is equals to true. There is an argument that is called numerical only, and you can just pass this. Now it will give you the correlation only for the numerical data, and we know that we have a limited numerical data. And let me just make it round up to 2 digits, right? And you know that, guys, we have three types of correlation. The first one is called positive correlation, negative correlation, and the no correlation. The one who are on the negative side is a negative correlation. The one that are on the positive side is a positive correlation. And you can just say कि age has 100% correlation with the age, and we know that each diagonal one each diagonal one has their 100% correlation because it's a correlation between the same value. Okay, so you can just say credit card score and credit score have like the same correlation. Now what you need to just check, because this is the target value, right, insurance bot, so you just have to check the correlation between the x features and the y features. And x features are like age to insurance bout correlation, so you can just check age to insurance bout correlation is like 0.76 and it is 76%. It say when the age is increasing, the chances of correlation are on higher side with the insurance bot, right? And same with the salary portion as well. It is like positive 72 percentage. And same with the credit score, it's like positive 73 percentage. But there is a negative correlation with the previous claim, and that is zero point 0.6 or minus 0.6, like means 6 percentage. Okay, and you know that the insurance bot and insurance bot has the same correlation because these are the same variables, right? So this correlation is very important before starting the ML model creation. It just gives the glimpse or the idea whether we are like going towards a proper features or not, where whether we are selecting the good features or not, right? So this correlation is very important. I hope everyone is getting my points, right? So let's just start with the model building. Okay, so before I just start the model building, can anyone let me know if there is any doubt, right, guys? Everything is sorted or clear? Just let me know, everyone. Ananya, Apeksha, and the rest candidates. Okay, candidates. Now, let's just understand the feature engineering. And we know that feature engineering is a technique to convert textual data to numerical one, right? It is a technique to convert textual data to numerical one. And we have two different columns and both are textual in nature. So let's just pick both column, right? We have multiple methods to use in this feature engineering. The first method is called one hot encoding. Just let me know if you are aware with this term, guys. Just say yes or no inside the chat box. Just say yes or no. The second one is called label encoding, ordinal encoding. These are the techniques inside a feature engineering, right? You can just also use the pd.getDummies, and pd.getDummies is nothing. It's same as the one hot encoding, right? And the fifth one and the like the fourth one is called mapping technique, and we are going to use this one because this one is very easy, right? And the data set is very limited right now, and we have just only two columns. That is the reason we are using mapping technique, and I'll let you know why we are using this mapping technique, right? And this mapping technique generally based on two mapping technique. The first is called lambda technique, lambda, lambda technique, and the second one is just as like a apply map or like a dictionary kind of something aspect. In generally we use a dictionary method, right? So we are going to use a dictionary method, right? Now let me just show you how to do this. Let's just pick first column, and the first column is like the gender column. You know that gender column has only two values, right? The first one is male and second one is female. Can I say let's just consider male as a value of 1 or 0? You can pick anyone. If I consider male as 1, so female by default becomes 0. Yes or no? And if I pick female as 1, so the male by becomes 0. By default becomes 0. Is that clear, right? So can I say this, candidates? We don't know about that. Okay, Apeksha. See, it's very important, right? To understand all these techniques. This one is important for like interview point of view as well. And if you want to be a good ML engineer, this feature engineering is very important, right? This is one of the most asked interview question. What do you understand by feature engineering, right? And these are the techniques to be implemented inside a feature engineering. Okay. So DF gender, inside this DF gender, let's just apply the mapping technique, and you can just say inside a map, you have to pass the dictionary. And we know that the first technique is called a dictionary technique, and second technique is called a lambda technique, right? So inside a dictionary, what you can do, you can just say if we are getting male, so let's just convert this to one. And if we are getting the female one, the spelling should be correct, guys, right? because the Python is case sensitive na. Although you can handle this with the some sort of Pythonic approach, but let's just keep it easy for right now. So if we're getting the male, let's just convert this to 1 and the female has to 0. Once you run this, and you can just easily check, okay, each male converted to 1 and the female with the 0 1. Yes. Okay, can it? Now you can just say what we want. We want to reassign the same value to the gender part, and you already know that we can update the value like this. Okay. Now once you run this, and let's just run a df.sample, and you know that the each gender value converted to 0 1 and the numerical one, right? This is called a feature engineering technique. I think, guys, this one is very easy, right? And the mapping technique is the one of the easiest one. What you have to just do, you have to just map the value. And how do we have mapped this value? You simply create a dictionary with the key and the value pair. I think this one is very easy, right? Just let me know, is there any doubt of this mapping technique? Candidates, anyone? If it is like any problem, just let me know. Do it fast. Class. Okay. So let's just apply the same mapping technique to the metal status one, right? Okay. Now the problem with this mapping technique, now first of all, we need to check the unique values, right? So you can just say, okay, inside this marital status, first of all, just check the unique values. For that, you will run this unique, and inside the unique, this will give you the value like this: single and married. If they're getting multiple values like single, married, something, divorce, and unplanned, yeah, whatever it is, so it's very complicated to give the key value pair for each mapping, right? So in that particular case, you can use different types of encoding technique, right? So let's just use the mapping right now. So what you can do, just simply copy this series. You know that this one is series, right? And apply the map. Okay, can I just show the lambda technique, candidates? Can I show the lambda one? Because inside the map we have already used the dictionary technique. Can I show the lambda one? Just let me know, candidates. Okay. So what you can do inside the lambda, we have a function that is called apply function, right? Apply allows us to write a row-wise function so that you can easily deal with the row-wise value. Apply is like do some operation at the row level, right? And you can invoke any function. So what it says ki you can just pick a lambda. A lambda is like an anonymous or like a one-liner function that generally picks a row. A row is like a single row. And what it will do with the row, you can just say if my row, if the value of row is equals to single, if the value of row is equals to single, it should be like 1, or you can say 0. You can give like whatever it is. Okay, there is no such issue for that. And if it is not a single, you can just simply say the else, and else is like the 0. Okay, and once you run this is the lambda technique, right? And you are getting the same answer. Now just let me know which one is good, right? I hope the dictionary method is the good one, right? Because it's my lambda. Inside this lambda you just need to do a lambda function or like an anonymous function, right? So you can use the mapping technique with the dictionary one, or the lambda technique with the apply method one, right? Both will give the feature engineering context. It's like textual to numerical one, right? So let's just reassign the value to the marital status. Let me know if everything is clear, candidate. If you got this point, what is the use of lambda inside this, and how to particularly use this method for feature engineering purpose. Guys, let me know in the message box if you're getting this point. So we have successfully reassigned this value, and let's just check the sample again. Okay, now you are getting the every one value, or like every feature or target is like numerical in nature. And how to just clear it, how to just cross verify this, you can just simply write the info. And we know that if we are getting each information as an integer or like a float, and we have successfully converted textual to numerical one. I think the feature engineering, the portion of the feature engineering part is clear, right? Sir, is lambda is anonymous function? Yes. Oh, okay, yeah, lambda is anonymous function. But can I ask the question, why lambda is anonymous? You can just say lambda is anonymous function, but why it is anonymous? It is anonymous because we don't need to reassign this lambda to any function. We can run it at a runtime level. That makes it anonymous. Okay, because we no need to assign, or we no need to restore or like store this lambda to any variable. We can simply run this function, and that is the reason we are saying this lambda as an anonymous function, right? Okay, we can run it at runtime. That makes this lambda as anonymous. I think it's clear, right? This is a part of Python question, and sometime interview also asks this question: what do you understand by lambda function, and why we call this as an anonymous function, right? And you can just check. See, apply method generally takes a function. It should not like you have to give a lambda one. You can simply give the like very basic function. Can I show this? Instead of lambda, can I use a basic function? If you are allowing me, if you are allowing me, I can definitely show you. Can I show this? How to do the same without the lambda function, just with the basic function? Guys, just let me know. If everyone is interested, then I'll show you. Otherwise, I'll skip that part. It's not like that much important, but if you just want, I can show you. Like without lambda, can we do the same like with the apply method? We can do, right? Just let me know. If I receive the multiple requests, then I'll probably show. Okay. Now, so let's just move to the rest part. Now we have successfully converted the textual data to numerical. Now what to do? And we know that because we have converted the all textual to numerical, so it's important to again run the correlation. Why? Because in the previous stage, the correlation generally works with the numerical. But since we have the two textual data, that is the reason we have to pass this argument, right? Now we have all data numerical one, and df correlation will not give you the error, right? So you can just simply round up the value, you can run this correlation, and now you are getting the multiple things, right? Sometimes you no need to focus on the complete matrices. What you can do, what you just want, let's just compare my target value. We know that this one is target with the features one, and age, gender, salary, credit score, previous claim, metal metal status, all are like my features. So what you can say, inside all this data, we just only want the last column, and we know that we have a technique for that, and that technique is called iloc. Iloc is like index based location. So you can just say, I want a complete rows and just the negative one column, or like the minus one column, and this will give you the minus one column, and we just only want this. What exactly the correlation of age to insurance bound, gender to this one, salary to this one, credit score to this one, previous claim, and so on. And this is the correlation between X data, or like the features data, with the target one. And if you're not satisfied with this, then the final step you already know. You can simply just plot a pair plot, and the pair plot will give you the multiple combination of each your data frame. And you can just show this. And this is the last part of this EDA. Let me just run this, right? Okay, and you can also do one thing. Instead of directly running this, you can just pass the hue value, and hue is like it will convert the value to a positive data, or like a numerical data. It will try to show the target as well, right? Like which type of data fall under the insurance bot category, and which one is not, right? And we are getting the data like this. And let's just check. The insurance bot one are like in orange in color, and rest are like in zero, or like blue in color. Okay, and it shows these are the data set, right? And how to just understand the pattern, right? You can just check the credit score which falls below the I think the value should be around 680, right? The credit score which falls below the 680, generally they are not likely to buy the insurance. Can I say this now? Just let me know, candidates. Even we haven't created any ML model right now, and just with the sake of with the use of this pair plot, we are generating the insight, or we are like understanding the problem. Can I say this? The customers which the credit score falls under this 680, they're not likely to buy the insurance, right? And that is completely backed by the data. It's not like I'm randomly saying this. And again, one who have like the salary more than 42,000, they're likely to buy the insurance, and the salary less than 40,000, they're not likely to buy the insurance. Can I say this statement now? And this can be easily visualized by with the help of a pair plot. Just rest candidate, let me know. Is that clear now, everyone? Right? So in this way, we can simply see these are the steps that are involved in a exploratory data analysis. And you know that since directly jumping to the ML model, it's very important to understand your data, and whatever we are performing each day is a project day. It's not like we are learning, we are just building something, and that is like the day-to-day project building. Okay, so you need to be more focused so that you can understand it proper. Now let's just start with exactly the model building, right? So what exactly this one? I think this one is the step 3, step 4, I guess, and it is like the model building. Okay, and the model building is like the first thing that we need to do is to convert the data into feature versus target. So you can just say feature versus target, and we know that x is are the feature one, and you can just say we know that the last column is the target one. So you can just say pick the complete df, pick all the rows, and just eliminate the last column. In this way, you can slicing the data, and you can just check you are getting the complete X data frame, and that's your all attributes or like your all features. This is your features. These are the features, right? Where age and marital status starting to ending, right? And you can just easily get the target value as well. df.ilog, just simply call all the rows and the minus one column. Minus one is like the negative column or like the last column, and this is your target data. Guys, let me know in case of any doubt in this step. Everyone, is everything sorted or clear? We have divided the data into two parts. The first one is feature part, and why we are representing this as a capital or like a big X, because we have a multiple features and only one target value. See, inside this one column, we can have multiple values like target 1, target 2, target 3, target 4. But at the end, we have only end with the one column. And that is the reason we are representing this as a small y. And with the big X is like we have a multiple features. In case of any issue with this class, let me know fast. Apeksha, Rakesh, and rest other candidates. Class, is everything clear? Everyone? Okay, so now let's just divide this data into a training and testing part. Okay, let me just check. It's clear. Perfect. So inside step 4, let's just start with the step 4.2, dividing data into a training and testing part. It's like a train test split, right? And we know that we have already imported the train test split. So just simply call the train test split and just simply give the x and y. Decide the test size. That by default test size is the 20%. You can randomly call the state, and the by default state is 42. It's like the popular state where every ML engineer use this state. It's just like you're shuffling the data. It's a random value. It's a random seed value. Okay, and it will, and you can unpack all four values. The first values are like x train, and the second is like x test. The third is like y train, and then y test. Now you need to unpack all these values. This technique is called unpacking. If anyone asks, na, what is this? Why we are writing all four values here? This technique is called unpacking. And let me show you, na, if you are not familiar with this one, na, let's just take example like this: a comma b comma c comma d, and we have a four values like 2 comma 3 comma 4 comma 5. So this is the unpacking technique to directly store inside a, same as it is 3 with the b and 4 with the c and 5 with the d. And if I just simply print the d, I'll get my answer 5. If I like print c, I'll get my answer 4. And this technique is called unpacking technique. I hope everyone is clear with this term, right? This is the interview question as well, candidate, right? Just keep this example, or you can also explain with this example, right? This is a shorter example, and this one is the exact use cases: explain access, y train, and y test, right? Now we have completely unpacked this data into a training and testing part. And the third step is like 4.3. We need to call a model, and we have already aware with the logistic regression. So let's just import the model. So model is equals to logistic regression. Inside this logistic regression, we can pass multiple parameters, and that those multiple parameters are called as a hyperparameter tuning. Guys, am I audible now? Candidates, am I audible? Just let me know. Okay. This model dot fit is a learning stage. We already know this, right? And what you have to give the question papers that are designed for the training purpose. So you have to pass the X train and the Y train. X train is like the actual question, and Y train is their code. the model get fit automatically, right? Once the model fit, now you can predict the value. And you know that for that you have to use the predict function. Predict comes with two different functions. The first is called predict probability, and the previous one is the first one is like the predict, and the second one is predict probability. Now inside this predict, you have to pass the text parameter or like x dot test data, or like the one data that you have just stored for the test purpose. Once you run this, this will try to give you the value. Now why we are getting the 101011? It's like the numerical output for the target one, and we know that our target are exactly stored in a y test data. Now what you have to do, you can just simply compare. This one is the predicted value and this one is the actual value. So let's just store this data inside a ypred, and ypred is like the prediction that has been predicted by the model. Perfect. This is the ypred data. Now let's this ypred data, and this one is your original data, so let's just convert this to values as well, so that you can easily compare this. The actual value was 1. It means the customer will likely to buy the insurance, and the predicted value is also 1. Is there any difference, candidate, that we are getting? Just let me know, is there any difference? 1100111000111111. What it likely to say? It says that the model could be like overfit, because whatever the data that we have stored for the training purpose or for the testing purpose, and the model has predicted the exact answer that was actually it is, right? And it exactly represents the model has the 100% of accuracy. It is not the practical answer, because in the practical situation you are not likely to get the 100% of accuracy. You could face like multiple problem related to the accuracy. Okay, so let's just check the accuracy first of all. And we have two types of accuracy. The first is called training accuracy. Candidate, am I audible now? Because I am getting some message or like notification from my Bluetooth. Uh, the charging percent is 40%, right? Okay, just let me know, right? Am I audible now? Okay. So we have two different types of accuracy. The first one is called a training accuracy. Okay. Now inside this training accuracy, you can just simply check model.score, and you can give the training data x train comma y train. This is your training accuracy. And you know that because the data set is very limited, or like the data set was very small, you're getting the 100% accuracy. See, accuracy can be like, it can particularly give the wrong meaning as well. Okay, so you have to avoid this accuracy sometime. We have a different matrices in the classification problem. So before just directly start with the different matrices, let's just check the testing accuracy. Okay, and inside this testing accuracy, what you can just check, you can just say model.score and check with the x test and the y test. Because all values look same, again you will get the 100% score. Again I will repeat, candidate, this is not the exact scenario. You can get the score like 87%, 57%, 37%, or like 30, 20. Even you can get the negative score as well. Okay, now it's your task just to let me know in the next class, when can we when we can get the negative score. What can be what could be the scenarios where we are getting the negative accuracy? Just let me know. Okay, you can just do this homework now. This is a very basic interview question, right? When we can get the negative accuracy. Okay, if someone wants to say right now, then they can message here, right? Otherwise you can just explore this, right? Okay, so right now we are getting the training accuracy as 100% and the testing accuracy also as 100%. It means our model performed well on training portion as well, or like the mock test, and our model also performed well on the testing part. It's like on the original board paper, or like on the original test as well, right? This is due to the less number of data, this is due to the overfitting of the data, or this is due to the very clear pattern that's been generating inside the data. And the major problem, or like the major opinion I can say why we are getting the 100% of accuracy, because due to the clear pattern. In the exact scenario, the data pattern, or like the correlation kind of scattering should not be like this. This one is very neat and clean. in the practical scenario you can get the multiple different patterns, right? That is the reason you need to understand you are not always getting 100% of accuracy. Okay, so right now we are getting the training as 100 and testing at 100% of accuracy. Now what it say, whatever we are predicting, we will get the exact 100% accuracy or exact 100% result. Okay, now when it comes to classification model, binary classification, we have a different parameters, or we have a different matrices to evaluate this. Okay, let's just re-understand this. In the regression problem, we simply uses MAC, MAE, RMSE, R2 score, adjusted R2 score, all these matrices, right? But in logistic regression or any sort of classification problem, right? Or any classification, we're not allowed to use any of these matrices. This is wrong, right? Uh, my student were like giving the interview, and interviewer just asked, can we use the R2 score or like MA, MSc to evaluate my binary classification model? And due to some pressure, it just said yes, and that was the reason he got rejected, right? So you need to understand ki we have a different stages, and we can only use those matrices in their particular problem, right? So inside this logistic regression or any classification, we have some matrices, and the first one is called accuracy score. Okay, the second one is called recall score. The third one is precision score. You can just check the F1 score as well. Okay, accuracy, precision, recall score, F1 score, and we have sensitivity as well, right? And we have some like confusion metrics as well, right? And not only this confusion matrix, we have another term that is called classification matrix. Okay, and every score that we are writing, where it is like accuracy score, recall score, precision score, F1 score, confusion matrix, classification matrix, all these are completely based on this confusion matrix, right? Once you understand this, what is this confusion matrix, right? So you can simply understand any of these. Sensitivity, sometimes we say this sensitivity as a recall score, right? So let me just write this. Some people say this as a sensitivity, SENSITIVITS. Some people say this as a sensitivity score, and some generally refer this as a recall score, right? And you can just check the, we have another score as well, that is called specificity, right? Specificity score. So we have multiple scores, right? And all these scores are generally used in this classification evaluation. What do you understand by all these scores, candidate? These are the matrices and these are the methods to evaluate your model. The same we did in the linear regression with some sort of matrices like this. And how to understand completely based upon this confusion matrix. Once you understand this confusion matrix, you can easily understand the any score. So let's just start with the confusion matrix. Okay, candidate, just let me know, is that clear now? We have already calculated the score, right? Accuracy score is the model dot score, and we know that the accuracy is 100%. So with all of these score, we have simply calculated this one. Now let's just start with the confusion matrix. See, the term is already clear. It's a matrix that generally try to confuse, because it's completely wants to check the possibilities. Now we know that once we are creating the model, and it could be like possible, we have four different possibilities. Suppose the model could be like related to this, whether the consumer will buy credit card, or like let's just take an example of this insurance one. So we have four different possibilities, right? Let's just take this possibility, right? This one,
We have one answer from like actual answer and the model answer, right? The actual answer is like yes, consumer will like the customer will likely to buy the insurance, and model also say yes. The another possibility is like the customer will buy the insurance and model will say no, right? The third one is like customer will not buy the insurance, but the model say yes, it will buy the insurance. And the fourth possibility is like the customer will not buy the insurance, but the model say, can it, am I audible now? Hello? Guys, am I audible? Hello? Okay. The customer say the customer will not buy the insurance, and the model also say the customer will not buy the insurance, right? So these are the four possibilities, and we know that yes and no are like the binary classification, and the confusion matrix is like is just like to compare the actual result with the model result. And we know that we have four possible uh, we have four different possibilities, either yes yes, yes no, no yes, and no no. And now just let me know which one are the correct one and which one are not. We know that actual answer, whether the customer like where the customer is likely to buy and the model also say buy, is the right answer. It means both are right. Okay, the customer will buy the insurance but model say no, so model becomes wrong, so the output is wrong. So you can just say right output or wrong output, like right output and it's wrong output. Okay, it has like model has some mistake here, right? So you can just say, and again this one, actually the model will not like the customer will not buy the insurance but model say it buy, right? It will buy. Yeah, he or she will buy. So this is again a wrong output, right? This is a misclassification by the model, and this one is again the right output. Guys, are you getting my point now? So in this confusion matrix, we have four different possibilities. Guys, are you getting my point? Just let me know. Am I audible now? Apeksha or rest candidate Rakesh. So we have four different possibilities, and that possibilities can be represented by confusion matrix. Okay. Now let's just draw this confusion matrix. Okay. So you have to import all the matrices. So you can just say from sklearn dot matrices from sklearn dot matrices you can import everything, right? You can import accuracy score, you can import recall score, you can import confusion matrix, you can import classification report as well, right? And see, the thing is confusion matrix is the important one, right? Okay, let's just check the F1 score. Okay, so inside this matrices now we can import all the matrices, right? And let's just write done here. Perfect. And the first thing that you need to understand is the confusion matrix, because this is the important thing. Confusion matrix generally takes two answer. The first one is the actual answer and the second one is the model answer. And you can just check the argument. It will ask first thing, that is why true. Why true was like what was your actual value. The actual value generally stored in the y test. And the second one, it will ask for the y pred. And what is y pred? Y pred is like the model prediction. And once you run this, you'll get this kind of matrix. Okay, candidate, this 5002. Now just understand, this diagonal one should be the value. If you are getting any value on this diagonal, right now we have like 100% accuracy, that is the reason we are not getting even a single value. But if we are getting any value on this diagonal like this one, it means the model has some issues. Right now it is like there is no value in this diagonal, but we have the complete value in this diagonal. So it's say like we have a complete 100% model or 100% accurate model. And this is the confusion matrix. Now how to understand this matrix? Just go to this one, and we have a like complete module for this, because this derived with the help of, or like created with the help of sklearn. So you have to use the confusion matrix from sklearn so that you can understand, right? Confusion matrix sklearn, we have a proper documentation for this. Now click on this, and once you click on this, this confusion matrix can be represented by this. Okay, let me just take a reference of this. Okay, this is called the predicted value, and this one is called the true value. The true value is like what was the actual result, and the predicted value is like what exactly the model has predicted. So we also want to convert our confusion matrix like this. So what you can say, just go to your code notebook, and you can just say, let's just store this confusion matrix inside cm is like confusion matrix. And now let's just draw a graph, or like draw visual for this. So for that we'll use the heat map, sns dot heat map, and inside heat map just pass this cm and just show this graph plt dot show. Cm is not defined. Let me just run this, right, and run this also, right. This is the heat map. Now if you want to show the value, just like we are getting the values here, so you can just turn out the anot value, and it is like anot is equals to true. Okay, you can just write like this, and we are getting the value. The 5 12 are like the good value where the model are performing well. It's like this one output and this one output, and all these 0 and zeros are the wrong output. And since because we don't have any wrong output, that is the reason we are getting the 0 0 values. I hope everyone is getting my point, right? Now let's just show the label as well. The way we are getting the label here, like the predicted level and the true level, and instead of using the predicted level and the true level, let's just give another label values. So I'll use the x label as model answer, yeah, model prediction. Okay, x label as model prediction, and y label as the actual answer, right? And you can just check, this is the actual answer and this one is the predicted answer. Now we know that 0 represent the customer will not buy the insurance. Okay, so now how to read this, then I'll close this session, right? Just give me 5 more minutes, I'll close this session. Okay, so how to read out this actual answer? Okay, 5 customers say I'll not buy the insurance, or 5 customer not buy not bought the insurance, right? And model also say they are not likely to buy the insurance. Okay, so 0 represent they are not going to buy the insurance, and 1 is like they are going to buy the insurance. So actually 12 data represent they will buy the insurance in the actual scenario. It's like you have to read like this, there is 1, and 1 is like they will buy the insurance, and it was like 12 data. 12 customers said they will buy the insurance, and your model also predicted the 1, it means they will buy the insurance. It means your model has performed well in both cases, where they will not buy the insurance and where they will buy the insurance. Now let's just take this scenario. Your actual answer was 1, it means the model, your actual answer was 1, it means the actually customer bought the insurance, and they were like 0 customer, and your model also present like 0, it means there are no data, or like there are no misclassified data. So in short, your confusion matrix value should be lies in this like square boxes. It means you are getting the exact value, or like the good value, or like the perfect prediction. And if you are getting any value inside this square matrix, it means model has performed some wrong calculation. Like we are getting some values here, right? These are some misclassification, or like the wrong classification. Okay, I'll definitely explain this in next class in more detail, so that you can easily understand what is confusion matrix, right? Once you understand this confusion matrix, then we can get all the score, whether it is like accuracy score, recall score, confusion matrix, not confusion matrix, f1 score, sensitivity and specificity. Every score is completely based on the confusion matrix. So let's just keep it for now. In case of any doubt, just let me know, otherwise I'll close this session for the day. Candidates, Apeksha, other candidates, guys, just let me know. Hima, Neha, Pragna, Rakesh, and the rest candidates. Okay, I have one more concern, right? I I just generally insist you guys to speak, right? Is there any issue with your mic, or like is there any concern that you can't able to speak, or is something like it's not allowed you can you can speak, or is there any constraint? Because I just usually want to have a two-way conversation, so that you can understand it well, right? If you just simply listen, it is good, right? You are a good student, or like you guys are very good, but at least try some ask some questions, na? because I'll just only teach what should be the best, right? But if you just ask some question, like someone asks can we use the anonymous or like the lambda, so I can explain something new, and something new can be based on your questions, right? So I just simply insist to ask more question whatever possible, right? And the class pace is like little bit fast, I completely agree, because we have multiple things to cover. Let me know if you're not like particularly covering whatever like I am teaching, okay? Just let me know. I'll try to keep my pace low as much as possible, because the class hour is very limited, like 1 hour. If we are just repeating the same thing, and if I just give you the time to like rewrite all the codes, it hardly took like more than like 1 hour to complete all these things, right? That is the reason. So just take a like recap from these recordings, and you can probably understand what exactly that we have learned since last 3 days, right? So shall we just close session for today, or is there any doubt? Apeksha, Rakesh, Hitashri, Neha, Prajwal, Hima, Bhumika, and rest candidates? Okay, I'm not getting answers, so I think everything is sorted. Let's just meet tomorrow. Okay, bye bye. Okay, I'll share the notes and the like. You can just check the my GitHub link. This one, I've already shared this GitHub link. Let me just share it again, and you'll find the complete notebook here, and you can have a look of all the notebooks. Right? Let's just close this session. Right? Bye bye.